Hello, dear learners. Welcome to another discussion. Our topic is about refraction of light. When a wave or light ray moves from one medium to another, its speed changes. The direction of the ray may also change. This property of waves is called refraction and commonly occurs with light rays. A good example of refraction is when you see the bottom of the swimming pool. The light travels from the bottom of the pool through the water, then through the air into your eye. The light travels in such a way that the pool often appears to be shallower than it really is. When light travels from air into a denser medium like water or glass, it will refract towards the normal. However, when light travels from a denser medium into air, it will refract away from the normal. Take a look at this example. Light rays passing through a glass block. Step 1. Take note that there are two media present in this illustration, the air and the glass. The wave slows and its wavelength decreases as it enters the glass. As the wave returns to air, its speed and wavelength increases to their original values. Step 2. If the light ray meets the block at an angle, its speed and direction change. The ray returns to its original directions as it leaves the block. Step 3. As the ray enters the glass from the air, it changes direction towards the normal. The angle of refraction is less than the angle of incidence. As can be seen in the diagram, the light ray changes direction as it enters and leaves the block. In all ray diagrams, all angles of incidence and refraction are measured between the ray and the normal. Refractive index. The speed of light is determined by the material through which it travels. As it leaves one medium and enters another, it changes speed and so refracts. The refractive index is the extent to which light is refracted when it enters a medium. Refractive index is calculated as N is equal to sine I over sine R, where N is the refractive index of the medium, I is the angle of incidence, and R is the angle of refraction. A refractive index has no unit. Air has an index of 1, water is 1.3, and many types of glass are around 1.5. This means that light travels 1.3 times as fast in air than it does in water, and 1.5 times as fast in air than in glass. Here is an example. A beam of light hits a glass block. The angle of incidence is 55 degrees. The angle of refraction inside the block is 33 degrees. Calculate the refractive index. Here is the solution. Step 1. Work out the sine of angle I. The angle of incidence is equal to 55 degrees. So sine 55 is equal to 0.819. Step 2. Work out the sine of angle R. The angle of refraction is equal to 33 degrees. So sine 33 is equal to 0.545. Step 3. Divide sine I by sine R. Refractive index is equal to sine I divided by sine R. Substituting the values, we have 0.819 divided by 0.545. The refractive index is equal to 1.5. Refractive index. The amount of refraction is determined by the refractive index, the ratio of the speed of light in air to the speed of light in material. And that can be expressed using this formula: n is equal to the speed of light in air divided by the speed of light in glass. Here is a sample question. Please do this and write your solution in your physics notebook. Light travels at 3 times 10 raised to the power of 8 meters per second in air and 2.25 times 10 raised to the power of 8 meters per second in water. Calculate first the refractive index of water and second the angle of refraction for a ray approaching water with an angle of incidence of 55 degrees. That's all. This is Teacher Rose of Woodrose International School. See you next time. Bye.